This is lesson 7.6, subtract mixed numbers with like denominators. It is found on pages 337 through 340 in your workbook. So do you know what you call a denim expert? Yeah, if someone was an expert in denim, what would you call them? They would be called a genius. Genius. What are blue jeans made of? Moving along. So our learning target for this lesson is to subtract mixed numbers with like denominators. And as always, I hope you can do it on your own by the end of the lesson. Alright, so our look back once again, we're going to shade to show each mixed number. So let's go ahead and do that. Alright, now it wants us to use the models to find each difference. So we've got one here that we can mark out, 1/5, 1/5. So now we have 3/5 left over. Alright, and then with the 1 7/8 minus 1 3/8, we've got the 1 and then 3/8, 3/8. So we're going to have 4/8, 4/8 left over. And of course, I can divide them both by 4 to get 1/2. Alright, and then our key concept, we're going to subtract mixed numbers. To subtract mixed numbers, subtract the fractional parts and subtract the whole number parts. That's in our first example here. Or you can write them as fractions and then subtract this in our second example. So our first example we would use when we have a smaller numerator subtracted from a larger numerator. So 2 minus 1, we can do that. Right, so we do 5 minus 2, which is 3. And then 2/3 minus 1/3 is 1/3, so 3 and 1/3. Now, we can't do 3 minus 5, can we? So in a sense, we need to borrow. But in order to do that, what we can do is just do 6 times 5 plus 3. 6 times 5 is 30 plus 3 is 33, so 33 over 6. 6 times 4 is 24. 24 plus 5 is 29, so we do 33 minus 29, which is 4 over 6. And of course, we can divide them both by 2 and get 2/3. Alrighty, let's do some in-class practice. Our I can statement here says I can use equivalent fractions to subtract mixed numbers with like denominators. We're going to be doing that in just a moment. So I'm going to solve 1 and 2 with you, and then I want you to start solving them on your own. Alright, so 5 minus 1 is 4. 4 minus 2 is 2. 4 and 2/5. Alright, 7 and 1/3. Now I can do this one of two ways. I'm going to show you. I can do 3 times 7 plus 1. That's going to be 22/3. Minus 3 times 2 is 6. Plus 2 is 8. So 22 minus 8 is 14/3. And that's going to be 4 and 2/3. 4 and 2/3. But let me show you another way. And this way you would want to use when you have large numbers, right? So 7 and 1/3, I can't subtract the 2/3 from the 1/3, so I'm going to do what's called borrowing. So I'm going to take 6. I'm going to borrow from the 7, borrow 1 from the 7, make it 6. Then I'm going to add 3/3 to 1/3. Why 3/3? Well, 3 over 3 is 1. I'm borrowing 1, so I'm going to add to 6 and get 6 and 4/3. Then I have 2 and 2/3. Now I can subtract. 6 minus 2 is 4. 4 minus 2 is 2. So you will want to do that. You'll want to do that if you're dealing with large numbers. Otherwise, you can make them both improper fractions and then simplify at the end. Now, honestly, I like doing this all the time, but I'll show you both ways. All right? Go ahead and solve number 3 on your own, and then we'll go over it. So 15 minus 4 is 11. 10 minus 8 is 2. So 2/12. But I can divide them both by 2. So 11 and 1/6. All right. I want to see if you can do number 4. Try out number 4 and we'll go over it. 6 minus 3 is 3. 6 minus 6 is 0. So we don't have to put anything. Now, if you put 3 and 0/8, that's fine, but technically it's just 3. So number 5 is definitely going to be one of those that you want to borrow, because 100 times 11 plus 50, 100 times 7 plus 85, it's going to be a lot. It's going to be a big number. So instead, I'm going to make it 10. I'm going to borrow 1 from 11, and then I'm going to add 100 to 50. So it's going to be 150, right? Now, why am I adding 100 to 50? Well, because I'm adding 100 over 100, right? We want the same denominator, and we want it to equal 1. So now we got 7 and 85. Now, 150 and 85 are still big numbers, but a lot easier than 1,150, right? Okay. So 10 minus 7 is 3. 150 minus 85 is going to be 65. 65 over 100. Mr. Kramer, I think I can make those simpler. 3 and 13 over 20. Yeah, 3 and 13 over 20. So 3 and 13 over 20. Now, technically, 3 and 65 over 100 is not incorrect. It's just better to make them in their simplest form. Right? In our I can statement here says I can subtract fractional parts and whole number parts of mixed numbers with like denominators. So number 6, what we can do is make it 7. I'm going to borrow 1 from it, and 6 over 6. Why are we doing 6 over 6? Well, because we want it to have the same denominator that it's subtracting with. So 7 minus 1 and 3/6. We've got 6 and 3/6, or 6 and 1/2. 6 and 1/2. And again, if you put 6 and 3/6, it's not technically wrong, but I still want you to practice simplest form. Alright, try out number 7. Try out number 7 and then we'll go over it. Alright, so I want to borrow 1, make it 4/4, minus 9 and 3/4. So I've got 0 and then 1/4. Mr. Premier, what if I put that 0 there? Well, it's not technically wrong, we just don't need to put it there. So 1/4. Alright, so 8 through 11, we're going to compare using less than, greater than, or equal to. So on number 8 here, I've got 3 minus 3 is 0, 2 minus 1 is 1/3, and 3 and 2/3, well, I'm going to take out my whole numbers first, and I'm going to have 2/3 left. So 2/3 is greater. Alright, you try to solve number 9 and we'll go over it. Alright, so we got 3 and 1/5. And over here, we've got 3 and 0/5, or just 3. So 3 and 1/5 is larger. Alright, number 10, solve that one and we'll go over it. Alrighty, so 4 minus 2 is 2. 1/2 minus 1/2 is 0. Oh, you're thinking, wait a second. How can I do 3 1/2? Well, let's make it 4 1/2 minus 2 1/2. Right? Because 3 halves, we got 1 plus 1 and 1/2. So that'd be 2 1/2. So that would be 2 as well. So they are equal. Alright, and number 11, try that one and we'll go over it. Alright, so 6 minus 6 is 0. 3/4 minus 3/4 is 0. So basically 0. 6 minus 6 is 0. 3 minus 1 is 2. over 4. So 2/4 is greater. So 0 is less than 2/4. Okay. In 12 and 13, we're going to write the subtraction equation represented by the model. So we've got 2 and what is this? 1 out of 1, 2, 3, 4, 5, 6, 7, 8. So 2 and 1/8. What are we subtracting? We're subtracting 1 and 1/8. 1 and 1/8, and that's going to equal 1. Alright, you try number 13 and we'll go over it. Alright, so we've got 1 and 1/4, and we're going to subtract 3/4, and we're going to have 2/4 left over. Alright, number 14 is matching, so we're going to match these to each other. So we get 3 minus 2 is 1, 4 minus 1 is 3/5. Well, all of these are improper fractions, so I need to make this an improper fraction. So 5 times 1 is 5, plus 3 is 8. 8/5, way over here. So not only is it wanting you to subtract, it's wanting you to make them into improper fractions, alright? Go ahead and match the next 3, and then we'll go over it. Make sure and show your work. And matter of fact, let's make this a Jolly Rancher problem. You get them all correct and show your work, at least one Jolly Rancher. Alright, so 5 minus 2 is 3. 3 minus 1 is 2. 5 times 3 is 15. 15 plus 2 is 17/5. So look, it's 5 times 3 plus 2. And we're going this way. So 17/5, there we go. 6 minus 3 is 3. 2 minus 1 is 1/5. So 5 times 3 plus 1. 5 times 3 is 15. 15 plus 1 is 16/5. There we go. And then 4 minus 2 is 2. 3 minus 1 is 2. 5 times 2 plus 2. 5 times 2 is 10. Plus 2 is 12/5. Alright, 15 and 16. We're going to find the missing number. So on 15, I'll do 3 2/3. Well, 3 minus what is 2? 1. And then 2 minus what is 1? 1. So 1 and 1/3. See? 3 minus 1 is 2. 2 minus 1 is 1. Alright? I want you to try number 16. Try number 16 and then we'll go over it. 4 minus 2 is 2. 1 minus 1 is 0. Yeah, because there's going to be 0 halves here, right? Just don't need to put it there. It will just be 2. Alright, number 17 is you being the teacher. Your friend says the difference of 9 and 2 3/5 is 7 3/5. So he's saying that 9 minus 2 3/5 equals 7 3/5. Is your friend correct? Explain. I want you to go ahead and do that. Now, in your explanation, instead of words, you can use math. Okay? So go ahead and do that, and then we'll go over it. So is your friend correct? No. No, this is what it should have been. You should have done 8 5/5 minus 2 3/5, and it should have been 6 2/5. That is the correct work. Alright, let's connect this to real life. A replica of the Eiffel Tower is 6 inches tall. It is 2 2/5 taller than a replica of the Space Needle. How tall is the replica of the Space Needle? Well, what they're going to do, they're going to have to take 6 and subtract 2 2/5. They take 30/5, because 30 divided by 5 is 6, and subtract 12 fifths, right of this fraction, get 18 fifths, right? And then make it where it's 3 3 fifths. So the Space Needle's replica is 3 3 fifths inches taller. What could they also do? Yeah, they also could have done 5 5 fifths minus 2 2 fifths, and that would be 3 3 fifths. Okay, so either way, you can do that. All right, so think about that as you read and solve number 18. All right, so a model boat has a length of 10 1/2 inches. Its height is 2 1 inches fewer. How tall is the model? So minus 2 1/2. We've got 8 0/2. And how are we going to write that? Yep, we're going to write it as 8. All right, number 19 is a dig deeper. I would be absolutely impressed if some of you got this. If any of you got this, honestly, because it's a pretty involved one. I want to see if you can do it though. All right, and I will give you a reward for it. I'm not sure yet, depending upon how many people get it correct. The fewer that get it correct, of course, the bigger the reward. But I want to see if you can do this. So go ahead and do this and see if you get it right. All right, let's see if you got this. The total length of two model airplanes is 14 inches. The difference in the lengths of the airplanes is 3 1/3 inches. How long is the shorter airplane? Show your work. So we got 14 inches. We're going to subtract 3 1/3. Well, I've got 13 3/3 minus 3 1/3. So I've got 10 2/3. Well, I need to divide this in 2. So half of 10 is 5. And half of 2 is 1. So the shorter one is 5 1/3 inches. Did you get that? Did you subtract the right things? Hopefully you did. All right, let's look back at our learning target. Subtract mixed numbers with like denominators. Hopefully you can do that on your own by now, and that you can use equivalent fractions to subtract mixed numbers with like denominators, and that you can subtract fractional parts and whole number parts of mixed numbers with like denominators. Hopefully you can do both of those on your own. And you know what? Remember, just always remember, I love you. If you're at a number 2, I will be glad to help you. You just need to ask. And you peeps who are at a number 4 who can explain it to someone can help your peers who are at a number 2. All right, y'all have a good one.